water pass condenser and which formulas are used to solve the problems on two water pass condenser, and how to apply these formulas by using steam table as well as Mollier diagram. Let us first understand what is the construction of two water pass condenser. Now if we observe here, in this condenser water is flowing in opposite direction. If we observe, here is the inlet of water. So water is flowing in this direction, and here for the outlet of water, the water is flowing in the opposite direction. Now this partition of the water is made by the baffle. So here is the baffle I have shown. So this type of condenser is known as the two water pass condenser. Now if we observe the working of this cycle, then here in the boiler the water is getting evaporated and the high pressure, high temperature water is entering into this turbine and it is getting expanded. So at the outlet of turbine there is the water plus vapor mixture which is entered into this condenser and the condensation process is taking place. So here is the water plus vapor mixture, and at the outlet of condenser there is the saturated water. That means the phase change process is taking place, and during this phase change process heat released is getting absorbed by this water, and the temperature of steam inside this condenser remains constant. So only the heat released during the phase change process is absorbed by the water, and there is the temperature difference in between this water inlet and water outlet. Now this condensate from this condenser is again pumped to the boiler, and this cycle is getting completed. Now how to apply the formulas to solve such a type of problems for two water pass condenser? So for that we will solve one example. I will read what is the given question. A surface type steam condenser designed to condense 300 tons of steam per hour at 0.04 bar pressure and 0.9 dry. The cooling water inlet and outlet temperature are 15 degrees Celsius and 25 degrees Celsius respectively. The overall heat transfer coefficient in the condenser is 3 kW per meter square degree Celsius. The condenser has two water passes and tubes used are DI, that is inlet diameter 17.6 mm, and DO, that is outlet diameter 20 mm. Determine the number of tubes used in one pass and length of each tube if the water speed in the condenser tube is limited to 2.5 meter per second. So this was the given question. Let us first understand given data with the help of diagram. It is given that the mass rate of flow of steam is 300 tons per hour. So this is the rate of flow of steam inside the condenser. So I will write here that is 300 tons per hour. Then condenser pressure is given 0.04 bar. Then the dryness fraction is given. So we know that the fluid entering inside the condenser is the mixture of water plus vapor. So here the dryness fraction is given, x is equal to 0.9. Then inlet water temperature and outlet water temperature is also given. So it is 15 degree Celsius and 25 degree Celsius. Then overall heat transfer coefficient 3 kW per meter square degree Celsius. Then inside diameter of the tube and outside diameter of the tube is also given. So we know that this is the two pass water condenser and the water is flowing inside the tube. So inside diameter and outside diameter for this tube is mentioned, and which is in millimeter. Then the water speed is also given. So when the water is flowing inside this condenser, so water speed is 2.5 meter per second. We have to find out the number of tubes in one pass. We will move to solve the question with the help of steam table. Now in condenser, how this heat transfer process is taking place? that is heat transfer Q is equal to heat lost by steam, which is equal to heat gained by the water. So for that we have to write the formula. Now heat lost by steam. So what information of steam is available? So here condenser pressure is 0.04 bar and the dryness fraction is 0.9. So when the dryness fraction is given, that is the amount of water and vapor mixture is given. So at this pressure we will find out the enthalpy for this mixture. That is at the pressure of 0.04 bar, what is the enthalpy H for the mixture. So for mixture we will use here suffix F and G. So F is for fluid, that is for water, and G for gaseous, that is for vapor. So what is the value of HFG at this 0.04 bar? Now why we are going to find out this HFG? Because here the value of X is already given. So for that we will refer the pressure table. So saturated water and steam pressure table is there, and at 0.04 if we observe what is the value of HFG. So here HF, HFG and HG value is given. So value of HFG is 2433 kilojoule per kilogram. So we will mention this value, that is 2433 kilojoule per kilogram. Now if we put all the data, so what is the value of Q? That is heat lost by steam is equal to mass rate of flow of steam multiplied by HFG multiplied by X, which is equal to heat gained by water. That is mass rate of flow of water multiplied by the specific heat multiplied by the temperature difference. So MS is given 300 tons per hour. So we will convert this value in kilogram per second. So 300 multiplied by 1000, that is kilogram, and for hour how to convert second, we have to divide here 3600. Now multiplied by HFG 2433 multiplied by X 0.9, which is equal to, now what is the mass rate of flow of water? That is MW, that is unknown. Now CP specific heat, so we know specific heat of water is 4.2 kilojoule per kilogram degree Celsius, and temperature difference, so temperature difference 25 minus 15, that is 10. So when we solve this, we will get the mass rate of flow of water 4.35 into 10 raised to 3 kilogram per second. Now we will move for again the second formula for Q. So this formula for Q in terms of overall heat transfer coefficient multiplied by the surface area of the tube multiplied by the log mean temperature difference. So Q is equal to UALMTD. So if we observe the value of Q, that we can calculate here from this calculation, that is MS multiplied by HFG into S. And then what is the value of UO overall heat transfer coefficient that is given in the data. Now we will find out the value of log mean temperature difference. So it is related to the value for the heat transfer process, that is the heat lost by steam, which is equal to heat gained by the water. So what is the temperature of the steam? So we know that this temperature remains constant because in condenser only phase change process is taking place and the heat is absorbed by the water during the phase change process. So temperature of steam will remain same inside the condenser, that is from inlet to the outlet. So at 0.0 bar pressure, what is the temperature? So again we will refer here the pressure table, and in first column there is the pressure 0.04, and what is the temperature? So in second column temperature is given 28.6 degrees Celsius. So we have to plot here the diagram. Now we will solve this question or understand how to find out LMTD with the help of diagram. So from inlet to outlet of condenser, this temperature will remain same. So I will plot here the temperature of steam, that is TS. So this is the line for inlet, here is the line for outlet. So TS is equal to 28.6. Now this heat or temperature is getting absorbed by the water. So what is the inlet water temperature? 15 degrees Celsius. So I will plot here as a TWI, that is 15 degrees Celsius. And outlet water temperature is 25 degrees Celsius. So for outlet I will plot here the point, that is TWO, and that is 25 degrees Celsius. So now we will join these 2 points. So here these 2 points are connected. Now difference in between inlet of the steam and inlet of water is known as theta I. So I will plot here how to find out theta I. That is theta I is equal to 28.6 minus 15, and the difference in between this outlet temperature is known as theta O. So theta O is nothing but 28.6 minus 25. So how to find out LMTD? So LMTD is theta I minus theta O divided by log to the base theta I by theta O. So when we put the value of theta I and theta O, we will get the answer 7.5 degree Celsius. Now we will find out what is the total surface area of the tubes. So for that we will apply the formula Q is equal to MS HFGX, which is equal to UALMTD. So now this U overall heat transfer coefficient is given, LMTD, that we have calculated. So when we put the value, then we will find out the value of A. Now this MS HFGX, that is, we already know what is the value. So what is the surface area? That is 9015 meters square. Now for this surface area, we have to find out the number of tubes in each pass. That is, we have to find out the value of N. Now this is the 2-pass water condenser. So here number of tubes in each pass, that is equal to N, and formula for that is, if we observe mass rate of flow of water, that is MW is equal to, now how we will define the rate of flow of water? That is, if we observe this water is flowing inside the tubes. So this whole area of the tube is getting occupied by the water. So how we can define this MW? That is, we will take this area multiplied by the velocity of water multiplied by the density of water multiplied by the number of tubes in each pass. So here pi by 4 di square. Now why di is there? Because water is flowing inside the tube. Multiplied by the velocity of water. So that is also given in the question. Multiplied by the density of water. So density of water is 1000 multiplied by the N, which is equal to MW. So MW that we have already calculated. So pi by 4 into, now this di is given in millimeter, but standard unit is meter, so we have to divide by 1000 bracket square multiplied by 2.5 into 1000 into N, which is equal to mass rate of flow of water is 4.35 into 10 raised to 3. So only one unknown value, that is N, and N is equal to 7147. So this is the number of tubes in each pass. So this is the answer for first question. Now this is the 2-pass water condenser. So how to find out the total number of tubes? That is this N multiplied by 2. Now we will find out the length of the tube. So how to find out? So here how we will define the surface area. So surface area of tube is nothing but pi DOL. So pi DO, that is the outside diameter that we have to take and multiplied by the length of the tube. So pi DOL, that means what? The total surface area multiplied by the total number of tubes in the condenser. So total number of tubes, because there are 2 passes, so we have to take 2N. So 2N is the total number of tubes. Suppose there are 3 passes, then we have to multiply here with 3N. So we will put all the values. So one unknown value is there, that is L, and L is equal to 10.04 meter, and this is the answer of second question.